Okay, so next we're going to talk about types of enzyme inhibition. Before we talk about types of enzyme inhibition, I want to talk about what's called the Lineweaver-Burk plot. So the Lineweaver-Burk plot is a double reciprocal plot that we use because it makes a straight line, and it puts this in y equals mx plus b form. So I'm going to go ahead and write that out first. So it's called the Lineweaver-Burk. And the Lineweaver-Burk plot is a double reciprocal plot. So the Michaelis-Menten was the velocity versus substrate, and this is going to be 1 over the velocity versus 1 over the substrate concentration. So this is now going to be a straight line, and the important points on this line are going to be this x-intercept here is going to be -1 over the Km. Here, the y-intercept is going to be 1 over the Vmax, and then the slope of this line is going to be the Km over the Vmax. So now we've put this in y equals mx plus b form. So if we wrote that, y equals mx plus b, y is 1 over initial velocity, slope is Km over Vmax, times x, which is 1 over the substrate concentration, plus b, 1 over Vmax. So this is the form that we use when we talk about enzyme inhibition. So enzyme inhibition is going to affect these differently. Another thing that we talk about is kcat, the turnover number. We don't see enzyme concentration here, but another thing that we can calculate from these Lineweaver-Burk plots is something called kcat, which was the turnover number that we talked about in the last lecture. Kcat is the Vmax over the enzyme concentration. And then the catalytic efficiency is the kcat over the Km. And I'll post some examples, some practice problems to go through some of these calculations. Okay, but we use this Lineweaver-Burk plot to form a straight line, and we're going to look at this to look at the 4 different types of enzyme inhibition. Enzyme inhibition is either going to affect the Km or the Vmax. So we'll see this line move depending on what's happening with the Km. This will either be in front or behind, and the Vmax will either be the same or changed. So we're going to look at 4 different types. Well, we'll look at 3 different types of inhibition. Enzyme inhibition. So an inhibitor is something that binds to the enzyme with or without the substrate that can affect the affinity for the substrate. So they can affect the rate of the reaction. There's also another plot called the Eadie-Hofstee plot that we won't use, but it's also in your book and in the lecture. So let's talk about inhibition. Let's define it first. So the enzyme inhibition. So an inhibitor can bind enzyme with or without substrate. And it may affect the affinity of the inhibitor or substrate for enzyme. Okay, so we're going to look at all of these in terms of the Lineweaver-Burk plot. So the first type of inhibition is called competitive inhibition. So I'm going to draw all of these actually on the same graph. So I'm going to make one graph again. And I'll make my uninhibited in black, and then I'll draw everything else. So again, this is 1 over initial velocity. This is 1 over substrate concentration. And I'm just going to draw this line again. And this black line here is no inhibitor. Okay, so with no inhibitor, again, this is -1 over the Km, and this is 1 over the Vmax with no inhibitor. So now we're going to talk about 3 types of inhibition. The first one we're going to talk about is competitive inhibition. Competitive, I'm going to do in green. Competitive means it competes for the active site. So this inhibitor, whatever it is, it could be a small molecule, it could be another protein, it is going to compete for the active site. So wherever the substrate is going to bind the enzyme, a competitive inhibitor, it's called competitive because it competes for that active site. So the competitive active site does not affect the Vmax. It does increase the Km. So it's going to look something like this. So competitive inhibitor, I'm just going to write the Vmax is the same. Km is increased. And remember what we said last time. An increased Km means a decreased affinity between the substrate and the enzyme. So let's look at another one. Let's look at uncompetitive. So uncompetitive inhibition decreases the Vmax and it decreases the Km. And it also decreases the Km. But at the same ratio, the same slope. So it's going to look like this. It's going to be parallel to that one. A decreased Vmax and a decreased Km. And there are lots of examples of these in the slides. Okay, so that's an uncompetitive inhibitor. So an uncompetitive inhibitor does not compete for an active site, but it affects the catalytic event. So they are parallel lines, and it decreases the rate of the reaction. The next that we're going to talk about is something called non-competitive. Non-competitive inhibition. Non-competitive inhibition, the Km stays the same and the Vmax decreases. So non-competitive inhibition, the Km is the same, but the Vmax increases. Vmax decreases. There is a fourth type of inhibition called mixed inhibition. We don't have any really good examples of that we're going to cover in the next few weeks, so I'm not going to ask you to be responsible for mixed inhibition. I'll only ask you examples that use competitive, uncompetitive, and non-competitive. And I also will post some sample problems of how you can calculate some of these values, how to calculate Km, Vmax, catalytic efficiency, Kcat, and all of that. So that is enzyme inhibition.